Welcome to the second of 8 brief discussions on the high leverage practices from the book Principles to Action. This is practice 3, use and connect mathematical representations. In this session, we will define teaching practice 3 of the Principles to Action, consider the best practices for teachers, and connect practice 3 to the Danielson framework for teaching. Again, this comes from the book Principles to Action from the National Council of Teachers of Mathematics, and we'll be discussing teaching practice 3. If you'd like to read through all 8 practices, you may pause the recording and read them here. The Idaho Mathematics Instructional Framework, seen here, is a modified version of the 8 high leverage practices from the book Principles to Action. This would be practice 3 of the Idaho Mathematics Instructional Framework. Support students in connecting mathematical representations. Additionally, things that may be coming there, the state is probably going to change the Idaho Mathematics Instructional Framework to align more closely to the 8 high leverage practices from Principles to Action. I'd like to clarify a little bit more about what this practice means. A lot of times it can be associated with a teacher saying, show your work. While that may be part of it, that is not the entire idea of what this practice is. Teachers, so this is from an excerpt from the book Instructional Leadership in Mathematics Education. And it says teacher provides opportunities for students to use and discuss multiple representations to draw on knowledge and experiences related to the resources that students bring to mathematics, culture, context, experience, thus positioning them as mathematically competent learners. Students use representations appropriately to solve problems, make connections among representations, and discuss the advantages, suitability of various representations. We're going to talk a lot about this, but briefly here, it's more than just showing work. It's new learning should draw on experiences students have had in the past, and multiple representations will help students connect to the mathematics they are learning. To better understand this, I feel like we need to talk about how the brain works and why multiple representations are important. In the movie Inside Out from Pixar, the movie uses different colored orbs to represent memories. Unfortunately, this movie is not scientifically correct. That is, our memories are not stored on shelves with tiny people-ish people putting those memories on a screen in our brain. The way memories are stored is through pathways. When a memory is stored in the brain, various aspects of that memory are stored in different parts of the brain. For example, if you were going to remember your Thanksgiving when you were 8 years old, you might remember going to grandma's house. You might remember the smells. You might remember grandma's floury dishes. You might remember people who were there, how you felt, what the turkey smelled like, right? All these pieces of that memory are stored in different parts of the brain. And when we recall those kinds of memories, our brain is sending a circuit, a pathway of collecting all those different pieces of that memory and putting them together for us. So when we recall a memory, we're actually our brain is actually connecting a pathway, bringing all those different parts of that memory into one piece. This is important to understand as a teacher teaches mathematics. A math concept cannot effectively and efficiently be introduced and stored in isolation, like in the movie Pixar, Inside Out from Pixar. Students need to develop a pathway for their memories. Students will better make sense of and understand concepts as they're able to connect the concept to other concepts, ideas, experiences, and memories the student has. So just to reiterate, there is no math shelf in the brain where math stuff is stored. Our brain is storing all of these ideas in different parts of our brain. And so it's important that we connect to those previous memories, ideas, concepts. So in the book, Principles to Action, this diagram is displayed. Students should be able to make many connections to the math concept they are learning. There are 5 primary connections: visual, symbolic, verbal, contextual, and physical. If a teacher omits one of these connections, students are less likely to understand and recall math concepts. Pause the video for a moment and reflect on how this might apply to math concepts. Here is one example I'd like to show you. This concept is that students understand the distribution property of multiplication as it applies to multiplying binomials. Students are often shown the FOIL method here, where F stands for first, then outer, then inner, then last, and students are taught to multiply these together. Teachers can sometimes color code these or think of an elaborate story so that they can understand what the teacher is foiling. There is power in an acronym when students need to recall learning, and there's nothing wrong with teaching this way, unless the learning started here or it stops here. There's a little more that should be done. Namely, students should be able to see what's happening here beyond remembering the procedure. Additionally, the student should connect this idea with something they're familiar with. This could also lead if we just did FOIL and showing the students to do this procedure, then we would fall into the trap of mimicking. And we've discussed what problems mimicking brings in previous sessions. And so the important part is, again, there's nothing wrong with this unless we started here like, hey, the teacher says this is how you do it, and that, or we stop here like, this is how you do it, we're done, etc. I'm going to show you a few other examples that we can connect. So this is teaching the same concept and related to the area of a rectangle. This can be called an area model or a generic rectangle. On this model, the 2 binomials are the side length, and the task is to find the area. This allows students to connect with something they already know, how to find area. If the main concept is using the distribution property of multiplication, it may be worth the time for the teacher to discuss what distribution actually means. They might think of a mail carrier distributing the mail, or a shipping company in boxes, and or receiving food. That we went to a food distribution center, or we go to the food pantry. This can help students understand how distribution of the word, what distribution means, and how it applies to math in the same fashion. So if we've already talked about distribution, the conversation may be had that x and -3 are being distributed to the other binomial. Then the acronym FOIL makes more sense. Also, if they understand the idea of distribution, they can then apply this to not just multiplying a binomial by a binomial, but a binomial by a trinomial, which is one of their next steps. Each of these methods in isolation would be bad. And not bad, it would be incomplete. They all have their advantages and disadvantages, but by using each of these representations, it helps students make connections to the math concept that's being learned. Any one of these strategies in isolation will not complete and connect the learning into long-term retention and conceptual understanding. Taught together, the student is more likely to make those connections. Something I feel is important as we talk about mathematical representations is the author Jo Boaler. She is a mathematician. She studies at Stanford. She teaches at Stanford. She wrote the book Mathematical Mindsets, which is another great book study book. And she says this: some students think their role in math classrooms is to memorize all the steps and methods. Others think their role is to connect ideas. These different strategies link, unsurprisingly, to achievement, and the students who memorize are the lowest achieving in the world. It's not just enough, give me the formula, show me what to do, have them mimic. Those types of students are the ones who will underperform. Students should not spend their time memorizing steps and methods. They should be able to connect the concepts in many ways, and their time is best spent doing that. As a supervisor, here are some of the actions we can encourage teachers to do as they strive to create connections to the mathematics with their students. This chart comes from the book Principles to Action. Pause the video and read through what the teachers and students are doing. When you're ready to continue, unpause the video. One of the simplest strategies a teacher can incorporate is having their students draw their thinking by asking, can you show me what that would look like as a picture or a sketch? And that's not exclusive to story problems. In fact, I've been very careful and intentional on not using story problems in this video. I did that because when we think about models and representations in math classrooms, we normally think of story problems, of drawing a scenario. Teachers will regularly ask students to draw a picture when doing a story problem. The point I'm trying to make is that models and representations are not exclusive to story problems. As an example, we could add, subtract, multiply, or divide these two fractions, 2/3 and 3/4, procedurally. Student conceptual understanding will greatly increase if they are asked to model what is happening when they are asked to perform that math operation. Allowing them to see and manipulate a picture will provide evidence for their thinking. I'd like to connect this now to Danielson. If you look at the Danielson domains 1 and 3, you can see how using models and representations could reasonably be justified in multiple components. Pause the video for a minute to reflect on all the components that this could fall under. Press play when you're ready to continue. I'd like to highlight a few distinguished attributes that manifest themselves when students are using and connecting multiple representations. Pause the video for just a second and you can read through these. What other distinguished attributes might you find? Additionally, this diagram is from the National Council of Supervisors of Mathematics book, Instructional Leadership in Mathematics Education. This shows the progression of mathematical representations from teacher-centered to student-centered. You can pause the video here. I know I've asked you to pause several times. Pause the video here to read through this progression. Press play when you're ready to begin. Less is sometimes more when teachers scaffold representations. Students should be allowed to process and interpret the math using their own representations. This concludes our discussion of High Leverage Instructional Practice 3 from the book Principles to Action, Use and Connect Mathematical Representations. This also relates to the Idaho Mathematics Instructional Framework. Practice 3, Support Students in Connecting Mathematical Representations. As a reminder, this is the process for administrators in the Accelerated Learning Program that we're doing this year. I've made a few adjustments to this plan. In December, the learning is asynchronous, and we will meet together in January. If you have any questions, thoughts, or comments, please reach out to me.